Welcome to another math lesson. As usual, we are going to start with a warm-up. This should have been on the last box, and you should have already attempted these 4 problems. If not, pause the video, try these 4, and we will go over it once you unpause that video. For those who have done it, let's move on. Number 1, evaluate the following one: x equals 4 and n equals 2. So we are going to be plugging in 4 for every time we see an x, and 2 for every time we see an n. So I'm going to rewrite this. It's 3xn squared, which is 3 times x times n squared. So 3 times x is 3 times 4 times n, which is 2, and that's n squared, so 2 squared. So order of operations, remember PEMDAS, we know that this back portion of this problem has to be done first due to the order of operations. So 2 squared means 2 times 2. 2 groups of 2. So 2 times 2 is 4. This part's 4. The rest of the problem, I'm just going to drop it down. 3 times 4 times 4. Now that it's the same operation going all the way across, it's all multiplication, we can just go left to right. 3 times 4 is 12. Drop the rest down, and 12 times 4 is 48. So, pat on the back if you got 48 for number 1. No worries if you didn't. Hopefully next time we will. Number 2, a rectangular, important piece there, a rectangular sandbox has a total area of 11 1/4 square yards. If the length of the sandbox is 4.5 yards, what is the width? So since we are dealing with the area of a rectangle, we know that the area of a rectangle equals length times width. That's the formula that we're going to be plugging in these values for. However, it's asking for what the width is. So W is going to say W because it's unknown. So in A equals L times W, area equals length times width, I'm going to plug in 11 1/4 for A, since that's my area. Plugging in 4 1/2 for L, since we know that's the length, and then W stays W because that is the unknown variable. So now, split the problem up through the equal sign. Remember, that's our equator. Goes to the equal sign. That's what we do to one side, do the other. That's the sides we're talking about, either side of the equal sign. We got to get the variable by itself. Remember, isolating the variable. So we got to take the inverse of times 4.5. Since the W is getting multiplied by 4.5, we got to take the opposite of times 4.5, which we know is divided by 4 1/2. And to keep it balanced, since this is a balancing point, it's like a scale, what I do to one side, got to do to the other. So we're going to divide both sides by 4 1/2, and that's our new problem. Now, anything divided by itself is basically going to cancel out. Since 4.5 divided by 4.5 is 1, you don't need to write 1W, since 1W is just W, so then you just drop down that variable. However, the important part, this is the math problem we're doing, and it's top divided by bottom. So I'm going to do the work over here. It's 11 1/4 divided by 4 1/2. Now, this is kind of tricky to do if you don't have a calculator, and this is going to be on the calculator inactive stuff. So we're going to have to turn this stuff into improper fractions. Remember, we do so in the clockwise manner. Denominator times the whole number plus the numerator, so it's 4 times 11, which is 44, plus 1, which is 45, and the denominator stays the same, so this is 45 over 4, divided by 2 times 4 plus 1. 2 times 4 is 8, plus 1 is 9. The 2 stays the same. So now we have 45/4 divided by 9/2. Now when we divide fractions, remember, going way back, dividing fractions, we got to keep, change, flip. So we keep the first one, so this is 45 over 4, change division to multiplication, and we flip this, so 9/2 is actually going to flip to 2 9s. Basically just turning it upside down to its reciprocal. So now we have 45/4 times 2 over 9, multiply going straight across, and 45 times 2 is 90. 4 times 9 is 36. And if this is the inactive portion, you can literally just type in 90/36, and that'd be right. Or if you reduce it, this would reduce to 2.5 or 2.5. Any of those answers are acceptable. Number 3. A class attended a field trip and bought some programs and snacks. If the programs, which is represented by the variable P, cost $1.75, and snacks, which is S, cost $4, which expression could be used to calculate how much money the class spent? So we know whenever we see the S, aka the snacks, it's got to have a 4 next to it, $4, okay? Because each snack costs $4. So depending on how many snacks they buy, we got to multiply that by 4. Programs cost $1.75, so depending on how many they bought, which we don't know, but we know we got to multiply P times $1.75. Whenever we're calculating the total number of money spent, we're going to be adding these together. So it's P times $1.75 plus S times $4. And we know that $4 as a whole is just 4. So basically another way to rewrite this stuff is just that we don't write P times $1.75, there's going to be $1.75P, which means the same thing. Plus S times $4 is the same thing as 4S. So which one matches $1.75P plus 4S or 4S plus $1.75P? It would be B here. A cannot be right because it left off the snacks altogether. And combine the two, and we know we can't combine S and P because they are unlike terms. C is here to trick you because they flip the correlating values and variables. And we know D is not right because they're subtracting the programs from the snacks, which doesn't make sense at all. Number 4. Determine the volume of the figures shown below. This is kind of what we got into towards the end. Finding the volume. Area is length times width. Volume adds another dimension, so it's length times width times height. So there's 3 dimensions. So we got to count across. But we have to read, or we have to count all 3 dimensions. Across, back, and up. So if each little block has an edge length of 1/2, we're not counting 1, 2 by 1, 2, 3 by 1, 2, 3, 4, 5. We're counting by halves. So it's 1/2, 2 halves, 1/2, 2 halves, 3 halves back, or 1/2, 2 halves, 3 halves, 4 halves, 5 halves. So in your calculator, you can type in 2 halves times 3 halves times 5 halves, and you get 2 times 3, which is 6, and 6 times 5, which is 30. And then you do the bottom, 2 times 2 is 4, times 2 is 8, and that is correct. Or if you simplify this, 2 halves is the same as 1. So we could also do 1 times 3 halves times 5 halves. Anything times 1 is itself, so we can just forget the 1. So 3 times 5 is 15. 2 times 2 is 4. And if you notice, 15/4 is just 38 reduced. Or if you wanted to use the mixed numbers, if you did 1 times 1.5 times 2.5, you'll get the same answer either way throughout. If you simplify this to a mixed number, 4 goes into 15 3 times, which gives us 12. So that means there's 3 left over from the numerator. The denominator stays the same. So if you got any one of those 3 answer choices, you are correct. Moving on to our daily dose. We're dealing with the median, so go ahead and pause the video and try and tell me, what is the median of the amount of tickets sold this week? When you have the answer, go ahead and unpause it and we'll go over it together. All right, the first thing I'm doing when I'm solving a median is figuring out how many values there are. So we have Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday. That's an entire week, and we know that there are 7 days in a week. 1, 2, 3, 4, 5, 6, 7. So if you don't rewrite 7 values, there's literally no way to solve this correctly. And also when you're solving median, when you rewrite them, they have to be in order from least to greatest. So the first step is to rewrite them in order from least to greatest. And just to make sure I got all these written down, I'm going to check it. 27, check. 34, there's 2 40s, and then a 45, 46, 48. So we got them all. Now when finding the median, we just cross off the least, the greatest, the next least, the next greatest. Basically far left, far right, far left, far right, far left, far right, until you get to that middle number. And because there's an odd amount of values, there's going to be one middle number. So this 40 is our median. So the answer to this is 40. Now it matters which 40 it is, because if they ask you to analyze this, and if they say like how many days were more than the median, well, 1, 2, 3 days are more than the median. So that means 3 days would have been more than the median this week. But if they ask how many days were less than the median, we know that 40 is not less than 40, so this wouldn't count. So there should be just 1, 2. So 2 days were less than the median, 3 days were actually more than it. All right, moving on to some more ratio stuff. Today is going to be unit rate. Remember, unit rate, we got to get the unit or the denominator down to 1. So if I'm looking at this chart, we're dealing with the NBA here. This is the total number of points scored by 4 NBA players. We're going to list them in order from least to greatest from points per game. Now notice that points per game is underlined and in bold. That's basically the math problem there. Points per game, whenever we see per, that's basically going to be a division problem. So it's points divided by the number of games played, which is our own category right there. So with LeBron, he scored a total of 2,255 points in every single game in 82 games. When you divide it out, 2255 divided by 82 gives us 27.5 or 27.5 points per game. From the rest of the problem, you can pause it, try and beat me to it, figure it out on your own. If not, let's just go over it together. Points per game, we have 2107 divided by 75. That gives us approximately 28.09 or about 28 points per game. When you divide out Curry's, 1,326 divided by 51 gives us an even 26. And Harden's scoring 2188 divided by, whoops, that should say 72. And that gives us approximately 30.39 points per game, or approximately 30 points per game. So if it's asking for least to greatest, based on these numbers, who scored the least amount of points per game, you would say Curry, and then after Curry would be LeBron, and then it would be Anthony Davis, and last but not least, scoring the most points per game would have been James Harden in this situation. So hopefully you got those least to greatest. Moving on. Quick practice. You can probably do these on your own. Pause the video. Try these 4. We will go over it together when you unpause these. Read the problem. Make sure you know you're dividing by the correct unit. So usually whatever follows the key word, such as per, or whatever the singular vocabulary word is, that's what we're dividing by. Go ahead and pause it. All right, number 1. Jeff works for extra money in the summer. He earns $32.54 after working for 4 hours. So we usually do money over everything. In this case, it's money over the number of hours he works. So $32.54 over 4. We're looking for per hour. Per how many hours? Well, that's just per 1 hour. So we gotta get down to 1, and when you divide out 32.54, let's see if I did this right, 32.54 divided by 4, it gives you 8.135. And since we're talking in terms of money, money's always in 2 decimal places, so this 5 would make the 13 or up to 14. So you'd say he made about $14 per hour. So you got 8. If you got 8.135. Just know it'd be 8.14 per hour, $8.14 per hour. Number 2, Miss Murray can run 100 yards in 12.5 seconds. How many yards is she running in 1 second? So yards per second. See how seconds following the singular keyword, so it's going to be yards divided by seconds. Your tickets, yards per, fraction means per. Second, plug it in, we had 100 over 12.5. We're looking for just 1 second. Seconds on bottom, so the 1 goes right here. To go from 12.5 to 1, you just divide it by itself. So dividing each of these by 12.5, 100 divided by 12.5 gives us 8. And 8 over 1 means she is moving 8 yards per second. So that one is going to be 8. Number 3. This one is kind of written to trick you. It says how many calories are in a donut. So it's calories per donut. Even though they give you donuts first, Donuts is basically going to be the denominator. Since it's unit rate, the denominator is going to be on bottom. So we have calories per donuts. Calories per donuts looks like this. Plug it in, we have 160.75 calories in 8 donuts. We're looking for just one. A donut just means one of those. So we're dividing by 8, get down to 1. What I do top to the bottom is 160.75 divided by 8 gives us 20.09 approximately. 20.09, or you would just say 20 calories per donut. Last but not least, number 4, a student is mowing 6 lawns in an hour and a half. At that rate, how many lawns can he mow per hour? So we have lawns per hour. Plugging that in, we have 6 lawns in 1.5 hours. We're looking for per hour, that means just per 1 hour. Hours on bottom, so 1's on bottom. So we go from 1.5 to 1, divided by itself, divided by the denominator. So divide each by 1.5, and 6 divided by 1.5 gives me 4. And in this scenario, 4 over 1 means he is mowing 4 lawns per hour. So hopefully you got all 4 of those, or at least those made sense. So we are good to move on. These ones are a little more challenging. If you think you can tackle these on your own, be my guest, pause the video, or if you just want to test your ability, that's fine. If not, let's go over these together. Now, when I'm looking at this stuff, I gotta figure out what's being compared. So number 1, tomato plant is growing 4.5 centimeters in 3 days. So we're comparing how many centimeters in the number of days. So how many centimeters are given to us? Well, 4.5. In how many days? 3. It's asking how much the plant will grow in 1 week. And a week is 7 days. Well, here's the tricky part. 3 doesn't go into 7 evenly. So in this case, it's going to be 1 extra step. We got to find the unit rate, aka we got to knock it down to 1 before going back up to 7. We want to get it down to 1 because 1 goes into every whole number. So the first step is dividing it down to 1 and then multiplying back up to this final number. Well, to get down to the unit rate, we've been doing this, just divide both by 3. 4.5 divided by 3 gives us 1.5. This is the most important part of this question, or these types of problems. Excuse me. In that box is the unit rate. Once you have the unit rate, you can answer any question. Whatever that next number they give you, you just multiply it. Because we know going from 1 to 7, we got to multiply by 7. So I do top to the bottom. 1.5 times 7 gives me 10.5. So in 1 week, you would say the plant grows 10.5 or 10.5 centimeters. Based on that, you should be able to do the next 2 on your own. If you want to give them a try, go ahead and pause the video. If not, let's go over this. We're comparing miles and gallons. M over G, it's 175 miles in 5 gallons. We know eventually we are trying to figure out how many in 8 gallons. Well, we know 5 doesn't go into 8, so we got to find the unit rate first. Going from 5 to 1, we got to divide by 5. So what I do the top to the bottom, 175 divided by 5 gives me 35. What this represents is 35 miles per gallon per 1 gallon. And going from 1 to 8, we multiply by 8. So then 35 times 8 gives us 280 miles. So on 8 gallons of gas, this homie can travel 280 miles. Last but not least, a student is earning $217.50 for 30 hours. At that same pay rate, how much will the student earn after 8 hours of working? Well, if I'm looking at the units being compared, it's hours to hours, and I know that 30 divided by 8 doesn't give me a whole number, so it doesn't go into each other evenly. And since I'm comparing money, I would get in the habit of putting money over everything. In this case, again, it's money over hours. That's 217.50 for 30. We gotta get it down to 8. Gotta go down to 1 first since it doesn't go in evenly. So divided by 30, 217.50 divided by 30 gives me 7.25, which means this person makes $7.25 per hour. So in 8 hours, we just multiply that by 8. And 7.25 times 8 gives us 58, aka $58 made in those 8 hours. Moving on. Last slide, look at these tables. Kind of did this on the last lesson as well. Go ahead and pause the video, try these on your own. Once you got your answer, or you attempted it, think you got the answer, go ahead and unpause it. We will go over these together. I'm getting out of breath in these videos, out of shape. All right, let's look at the bottom left one first. Tanya's had a baking sale. Information in the table tells how much money she made during this bake sale. So it's asking, what is the most expensive item Tanya sold? So we're gonna have to find the unit rate, or what she made per item, in order to figure out which one's the most expensive. Well, we have money over everything, so in this case it's gonna be money per the item. So we're just doing the right side, the money divided by the number sold. So in this case, it's $48 divided by 8. That means each apple pie was $6 a piece. If you do the next one, it's $15 divided by 5, so that was $3 a piece for the corn muffins. Next one is $30 for 15 oatmeal cookies, so each oatmeal cookie was $2. And the banana bread was $30 for 6, so 30 divided by 6 is 5, so each one of those is $5. Looking at the most expensive one, that's going to be the apple pie. Since apple pie was $6, that's $1 more than the banana bread, so you'd say apple pie was the most expensive. Last but not least, look at the top right table. Spirit Club has set up a booth during the homecoming week. The information in the table shows how much money the club made on each item. Again, it's asking for the most expensive item. So it's going to be money over everything. In this case, money divided by the number sold. If you do $224 divided by 28, for this first one, you get $8. Next one's $80 divided by 5 fleece throws. So each fleece throw is $16, and even 16. Sweatshirts, $600 divided by 40 gives us 15. And for the team logo cap, $1,200 divided by 80 also gives us 15. So the most expensive item here is going to be our fleece throw at $16 a pop. Hopefully those made sense. If they did, you're good to go ahead and try the Bitly. If not, please go back, rewatch the videos, pause where you need to, take notes where you need to. It's important that we grasp this concept. Thank you for watching.